So yes, midterm will be on Wednesday. You're just going to click it on Canvas and take it. And, yeah. Then I need to give you a bunch of things after this lecture today. So let's get started. We're going to be doing a Python lecture for our one and only lecture this week, which is exciting to me to do a programming lecture on a Monday. So we're going to talk about a wonderful concept called turtle graphics. It's a way to have Python draw for you. It's going to be really cool. I'm excited to teach it. But before we get there, I would like to just give you like another example just to remind you what Python is all about, right? We learned a bunch of stuff last time. It may have been overwhelming. So I just want to like give one last example before I teach you something brand new that kind of reviews everything we went over last time, right? So let's go ahead and open up idle. Hopefully your computers have survived over the weekend. If they haven't, just go back and download and reinstall Python and open up idle. Sorry about that. If it's not there, but once we're all here, I'm going to make a new file for us, and I'll save it eventually. All right. But here's my idea. Here's my goal for a review. Let's have the user give us two numbers. So we're going to use the input function. Remember that. We'll ask them for two numbers, and we're going to get that first number, and we're going to take it to the power of the second number. So remember that it's ** in Python to do the power of operation. So we're going to make like two variables. Oops. Why is my pen too small? We'll get two variables from the user, or two numbers, and we'll shove them into two separate variables. Call it like num1 and num2. And then like maybe they give us 2 and 3, and our job is to go off and compute 2 to the third power, right? Which is 8 in that example. So yeah, that's the goal. And that's going to be our program. This might seem a little boring to you, honestly. I can imagine. Like, we're doing such cool stuff in Scratch, it might be a little boring to go back to, like, okay, let's just do some math with some variables right now. That's just because Python is a new language. It's something we have to learn how to speak all over again. So we have to start with simpler things. But I'm going to show you cool, colorful things later today. We're going to draw, all right? But in general, Scratch was, like, really good about holding our hand as we were programming. Python is lower level. It's going to take more Python code to write the equivalent thing that you could have written in Scratch. Okay, Scratch was giving you a lot for free, so we call Python as a bit more of a low-level language, which is going to be just kind of funny when you think about it if you know more languages. But that's okay. You have more control with Python, and I think that's a good reason to still learn it. Okay, so yeah, let's get this started. Let's ask the user for some stuff. We'll say input, right? We'll say input. And then we'll give them a little prompt, like enter a number, colon, space, or whatever, with quotes for a string, single or double quotes. Remember, though, that when you call input, it's going to give you back whatever the user typed as a string. So maybe the user, well, hopefully the user was going to type a number like 42. We're going to get that back as the stir 42, which remember we cannot do math with, right? The stir 42, if I do it in the REPL real quick, the string 42 times 2 is like just duplicating the characters. That is not math. That's not what we want to do. Okay? The power operation doesn't even work for that. So if we would like to get a whole number out of a string, if we like to convert the types, we say the type that we want. We kind of call it like a function, right? We say int with whatever we got, like num1 maybe, num2, right? And that will convert those types. So a very quick way to do it all at once is to say, hey, user, give me your thing. You say input. This is what I showed you last time at the very end. Let's get input from the user, give them a little prompt, right? Colon space. And then take that, whatever we got, 42, immediately convert it to an int. Chain these function calls, all right? And then shove that int then back into the variable once and for all, into like num1. Kind of read how that's happening. First, ask for the input, convert that input to an integer, and then take that into a variable called num1. All right, so it's a little backwards, that's how you might read it, but that's going to be the secret. That's how we're going to do it. All right, so I'm going to save this file in a place that you can have it later, and apparently this is lecture 14. So I'll make a folder for lecture 14. You can, of course, make yours wherever you want. Save your stuff wherever you want. Lecture 14, but this is how you can have it later. And I'm going to call this like power computation. Power for power. How.py, all right? So there it is. And so I want to do two things at the start. I want to get two separate numbers using this pattern, all right? So let's see if I can make this window smaller so you can see the pattern. There it is. So I'd like to say, like, let's see, what do I want to do? Let's comment it out, right? Get the first number from the user as an integer, not as a str. So I'm going to say input, hey user, enter the first number, colon space. This will stop the program, ask the user to type, they'll press enter, and then input will see whatever they got and give it back to us. We can immediately convert that to an integer, and then we can shove that integer into a variable like num1. Alright, so that's getting the first number from the user, and we can do it all over again to get the second number. Enter the second num, and we'll call it num2. So now we have two numbers from the user, okay? And what do we want to do with them? We would like to calculate the first one to the power of the second one. Calculate num1 to the power of num2, print the result, right? You always have to specifically say when you'd like something printed to the screen in Python. So it's a call to the print function. What do I want to print? Print the result is, like, you can give multiple arguments to print, remember, and it'll just space separate them. So like it'll print this, and then a space, and then we can give our computation here. Remember that it's not num1 caret num2 like it is like maybe in a calculator. It's going to be num1 star star num2. That's how you do it. All right, that's the power of operator in Python. Okay, and so in theory, if I go to run module, just type F5, it'll run it over here, and here it is stuck on the input line for the first one. Enter the first number 2, and then the second number 3, and then the result is 8. Beautiful. Enter the first number 3, second number 4, result is 81. And you can go crazy. Python numbers, they are big. They are very wide. They're as wide as they need to be. So you can be like, please calculate 2 to the, I don't know, 100th power. I'm just like, okay, sure. There's your answer. I can deal with very large numbers. But yeah, that's our program. Get a number, make sure to convert it to type. Num1, num2, I have those variables that are both ints right now. Let me do some computation on it. So that's hopefully a good review of everything that we kind of covered last time. Are there any questions about that before we go to new stuff? All right. So yeah, now let me show you this cool thing called the turtle library in Python. So there is a documentation page. You can look at it too if you'd like. You could just search Google for Python, just like we did Python math library. We could do Python turtle library. And it's a cool way to make graphics. So that's pretty fancy. And there's a whole lot of little functions in this library that move this. It's a virtual turtle. It's going to be moved around. It's really cute. All right. So here's the idea. Here's the metaphor. All right. So there is a turtle. All right. Here's what we're pretending. There's a turtle, and somehow this turtle, I don't know, he was in the wrong place at the wrong time. He got his tail dipped in ink. So here's my best artist rendition of a turtle. There he is. And then here's his tail. And he got his tail dipped in ink. All right. So there it is, dipped in ink. And he's also a trained turtle. He understands English. And the dude can move in whatever directions you ask him to move in, with his tail up or down. So you see where I'm going with this? So you can ask him to move in weird ways. And with his tail down, he'll make marks. And with his tail up, he won't make marks as he moves. But you can, like, draw dotted lines. Pick your tail up, move a little bit. Put your tail back down, move a little bit. Right? So that's kind of the goal. And you can make anything you want if you write the right program for it. Okay? So yeah, you can ask the turtle to move around and draw things with whatever ink color is on the tip of his tail. And you can ask him to pick his tail up so that we can move somewhere new to, like, not make marks for a second. All right? So there's a bunch of functions for that. There's like down to put your tail down and up to put your tail up. Okay. So with that in mind, here are all these functions. There's like go forward, Mr. Turtle, go backward, Mr. Turtle, turn left, turn right by a certain number of degrees. All those things you can do. Okay. It's like forward says go forward by a certain amount of like units in turtle land. Go forward by 25 units or something. Okay. So yeah, let me show this to you. It's going to be exciting. So what we'll do, just to start off, is we'll draw a square. All right? It's very simple to draw a square. The turtle begins his life right in the middle of the screen, which are going to be at coordinates 0, 0. There's going to be a coordinate system just like there was in Scratch. So the turtle's going to start off at 0, 0, and he will be facing to the right, right? East as far as the library is concerned. So he's facing east, essentially, at 0, 0. And we can tell the turtle, like, turtle dot forward, turtle dot turn left, all those things. Remember the dots, right? It's always library name, dot, what you want. And it's like the type. You kind of think of it like this, like, on the turtle, tell me your position. On the turtle, go left. You're, like, commanding the turtle with that dot kind of thing, okay? As if they belong to that turtle, okay? There is a nice helper function if you forget where you are. It's called turtle.position. It takes nothing, no arguments at all, just 2 open close parentheses immediately. That tells you where the turtle is, all right? So let's get started with that. Let me prove to you that the turtle is at 0, 0 facing east, all right? And then we're going to draw a square eventually. I'll make a new file, and I'll save it, and I'll call it square.py. Remember that we're going to use the turtle library. We're going to say import turtle, just like we said import math. Do not name your Python file turtle.py. All right? That'll ruin everything. It will forget where the library lived. That's my second word of warning. All right? So I'm going to say import turtle. And before we ask him to move anywhere, let's just like print his position. Print turtle dot position. All right? That'll tell us where he is, and that will prove to you when I run it. He's at 0, 0. And here's the screen. Here's a little turtle screen, and the turtle by default, he's just an arrow, so you can see him facing right. He's very small. All right. There he is. 0, 0 is where he lives. There's his coordinates. Perfect. So it is correct. That's his position, but that's 0, 0 in the middle of the screen facing right. Okay, that's the default setup for the turtle. All right. There are ways to configure what the turtle looks like, because why not? That's kind of cute and nice to have. So, like, if this is turtle graphics, I don't want an arrow, I want a turtle. There is a function for that. It is, where is it? Dun, 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 turtle appearance. You have turtle.shape. All right, turtle.shape takes one argument, which is a string, and by default, it's classic. You have a bunch of different options. Arrow, turtle, circle. Apparently we're on classic right now, but we can make the turtle look like a turtle by calling turtle.shape with a string argument turtle. That's just how the library works. So I would prefer a turtle over an arrow. I don't know about you. So let's make the turtle actually look like a turtle by calling turtle from the library. The nice library people made this for us. Come on, little window. There you go. I'll say turtle.shape, and I'll give a string turtle. All right. Remember that strs can be single quotes or double quotes. It doesn't matter. Whatever you like. All right, and so now, he's still at 0, 0, of course, but look at him, he's a little turtle now. Isn't that cute? And we can see his head facing right, so that's perfect. Still facing east. So there's that one. And now here's what you can do. All right, here's how you can command the turtle to do stuff. So you can tell him, go forward by a certain amount of units. Turtle.forward takes one argument. Then you can tell him to turn left, right? Turtle.left will make him like turn by a certain degree amount. So let's say, all right, he's going forward right now. He's going right right now. So if we say go forward by like 100 units, that could draw the bottom part of the square that I care about drawing. You see that? I would move him over to here, like 100, 0. Okay? So if I told him to go forward by 100 right now, he would make that mark. By default, his tail is down. So let me show that to you. All right? So I can say turtle.forward by 100 units. All right? Watch. Whee! There he goes, and he made a little line in that direction. Does that make sense? So just that function call, it was just saying, hey, Mr. Turtle, please move in your current direction by 100 units. All right? 100 units in Turtle Land. Does that make sense? Well, that's pretty cool. And so once we learn how to write fancier programs, we can make some very fancy drawings. We can also change the color. I'll show you that later. Maybe not today, though. And then, okay, well, now we're at the bottom, right, of our little square. We want him to go this way now, right? We want him to go this way so we can make the top part of the square. Yeah? So we need to get him to 100, 100. So he is facing right still, though. All right? So we need to turn him. If he went forward right now, I'd be going more that way. We want to turn him that much, right? We want to turn him to the left by how many degrees? 90 degrees. Yeah? So now we can say turtle.left. Turtle.left, 90 degrees. And that will get him oriented in the right location, right? So turtle.left by 90. And this is saying turn left, right? Turn left 90 degrees. Okay? Yeah, see how he's ready now? He's ready to go up. We went forward now. Does that make sense? That's pretty cool, I think. We're about to make a box. So we can prove to ourselves that, yes, his position is 100, 0 right now. We can reprint out the position right after we went forward, maybe. Just confirm, right? And I'm just rerunning quickly. You can always do run module, but I'm pressing F5 because it's quicker. And then, yes, you see how he's changed his coordinates there. So that's perfect. All right, so now he's ready to go forward. And if we want to square, we're going to go forward by the same amount. Right, the same amount that we went for the bottom. So go forward by 100 again, because now he's facing this way. And that will bring you to the new spot. By 100. And so I can just essentially copy and paste this, right? So turn left 90, then we're going to go forward by 100. Oops. There it goes, forward by 100. Okay? So forward, turn left, forward again. All right? So it seems to be working. I think you kind of get the idea now. I need to turn left again, right? Because if we went forward some more, he'd be going straight up. We don't like that. We got to turn him left again so I can get him going that way, right? Facing this way, eventually make your way to, what, 0, 100. So let's do that. So that's another left turn by 90, and then forward by 100. Keep that visible. Put this over here. So it's another left 90 and forward 100. All right? Just like that. Okay, and then I think you get the idea. If only we had loops, right? Because it's again another left 90, forward 100. Yeah, to close it off. Is that a question? Yeah. Do you mean the speed? Yes, I'm about to show you that actually. That's a good question. Yeah, I'll show you how to change the speed in just a second. But yeah, one more to fix it. To close off that square, he's like facing this way right now. I'm going to turn him to the left by 90 degrees one last time, and then that means he's going to be facing that way and go forward by 100 once more. Okay? There is a turtle.speed that I'm about to show you. Did I already copy and paste it? Do it again. In theory, that'll close it off. Not bad. All right, so yeah, this is kind of cool to watch the turtle work. You can change his speed to make him slower or faster. That's called turtle.speed. I assume it's somewhere in visibility. No. Where are you? Turtle state. There it is. It was in move and draw. Okay. So turtle.speed can take a few different arguments. It can take numbers as arguments. 0 is the fastest for some reason, and then 1 is the slowest. It goes 1 to 10 normally, and then like 0 is like no speed at all because you're super fast, I guess. So 0 is the fastest. You can also use strings to mean a certain speed. You can be like turtle.speed fastest, turtle.speed slow, slowest. I don't remember what the default is. Probably it's 5. I'm not sure. Or maybe normal speed is 6. All right, so you can make him super slow if you wanted. You're like turtle.speed slow. But you want to do this before he draws anything to configure the turtle at the start. All right, so turtle.speed is going to control the speed of the turtle in the future, right? So there's an order to it all. So we'll say up here, like when we change the shape, maybe we can also change the speed. All right. Oops, so we can say turtle.speed, like slow, and I'll use a single quote string this time. And so then all the future drawings will be slow motion. Kind of the same. I think it was slowest, right? It was even slower. There, he's much slower now. Look at him work. So that's kind of cool. You can also change him all the way to fastest, right? Fast or fastest. Fastest is faster than fast. But either one works. And just like this function call is again just saying like, hey, make the turtle go fast, please. And then you drew that really fast. Okay, so when you have very complicated things that take a lot of lines, you want to make his speed fast so that you don't get bored. Okay, But yeah, that's going to be the full program. Are there any questions about it or how it's working? You kind of understand how it's drawn that square? All right. So yeah, let me I'll keep the code up for you, so you can have it while you're looking. I want you to try. I'd like you to try to draw a second square, some distance away. Okay. And let's see. There are some other functions that you might want to look up as you're trying this, but we have time for you to try it. I think it'll be good practice. But there's a few different things that you can do. So like here's our original square, right? I want you to draw a second square somewhere else. Right? So right now the turtle is at the end of my code. He's facing downwards. Right? He's facing right there. And I want you to keep all that, but also draw some more squares. So like just one more square, like maybe over here. Or you can draw a square in the middle if you wanted to, or a tiny square up here. Just pick where you want. But one thing that you have to worry about is like if the turtle's right here and you want to move him like to this spot, he's going to make a line right now because his tail is down. Right? So the way that you pick his tail up to move is you say turtle dot up. Right? Turtle dot up, then do your movement. He won't make marks as he's up. Do your movement in between that, and then you say turtle dot down when you're ready to draw again. Okay? That's the first thing. That might be useful. And I'll give you this code in a second too. Turtle dot down is useful. And then also turtle dot set heading, if you want to look at that. That's also useful. Turtle dot set heading, you can give it a degree amount, and that will just warp the turtle's direction to that particular degree amount. So like if you say turtle dot set heading 0, that is east, 0 degrees, right? It's like math degrees. And this would be set heading 90. It would be 90 degrees. That would face him straight up immediately, regardless of where he's pointing right now. This would be 180, and this would be 270. All right, so turtle dot set heading might help you as well. Okay, so yeah, I think the easiest thing for me to do is I can't really show you that as well as the code at once. So here's the code for a second. Let me very quickly give you this code. If you would like. If you go to Canvas, I'm going to put this on the code from class page for today's lecture. All right, let's see. So like in like the second module or something. You click code from class, CSCI 1, there is now a lecture 14 folder that you can click on and see this exact code. Okay? So yeah, give that a try. Now that you know where this code is, it's on the code from class page. Try to recreate what I had and just copy and paste it in. And then draw a second square somewhere else. And you're going to have to tell the turtle to pick his tail up because you don't want to draw a mark in between your squares. All right? Once you're in position again, then you can put the tail back down. But yeah, give this a try. That's a good way to learn. And we will come back and I'll show you my answer. I'll give another square. All right? Oh, this wasn't water. Well, then just facing down right now after that first square. Just like turn left a little bit. Also turn right. Turn right by a certain degree. That would be useful, potentially. Either one works. Give you a couple more minutes and then I'll show you how I might think about it. Yeah, just like play around with forward. It's like forward and left, right? That's what we're using. See how far you can get. Consider up and down then, if you don't want your squares connected to each other. Alright, that was my time. I hope you got at least partway through it. Were there any questions that came up as you were trying it? I'll draw a square too, just for fun to show you how I might think about it. Which one do I want to do? I think I'll be lazy because he's already facing that way. I'll draw this square kind of, because then I'll just tell him to go forward some more, and you'll be in the spot for that square, right? That's perfect. So the turtle is sitting right there. If I tell him to go forward a little bit more, then I can make him move. Okay. So let's see here. But maybe I should also, maybe I should show you set heading, because I think that would be more useful too. So maybe I'll like draw a square over here or something. I'll figure it out one way or another. But yeah, let's get ready at least. Let me move this up so you can see it there. But yeah, let's draw a second square. And let me show you what set heading does. So right now, the turtle is facing down. I could, if I wanted him to face right, I could say, okay, turn left by 90 again. Or I could say, hey, turtle, set your heading to 0 degrees. That would force him to face right no matter what weird degree he's facing right now. Okay? So turtle dot set heading 0 will always force him to face right. So now he's facing right. Perfect. And now if I want to, let's say that I do want to draw a square over here to the right for fun. I want to move him by more than 100, right? Because 100 will just be right to there. Well, let's move him by like 150. I don't know. So turtle forward by 150. That'll get him in the spot to draw the next square. But notice how his tail was down, so he made a mark. We don't want that, right? So we want to pick his tail up before we get him into position, right? And that's going to be the turtle.up thing, okay? So if we say, hey, turtle, pick your tail up, then move forward by 150, watch. Now he's over there and he didn't make a line. That's perfect, right? So turtle.up was pick your tail up. And now let's say that I want to start drawing right there, so we want him to put his tail back down now, so he starts making more marks again. All right, turtle that down for put your tail back down. All right, so now if I move him some more, he will go in that new direction. Right, so now he's facing right again, and his tail is down, so if I move him forward, he will make a mark. Okay, so if I'll make a very small square, turtle dot forward by like 25, yeah, and then it's always turtle dot forward by something, and then turtle dot left by 90 if we're doing it in this way, right? So there he goes. He draws a little bit there, and you know that if you just do that a bunch of times, you'll pretty much get done with the square. Just copy and paste those. Almost done. One more thing to draw. Technically, you don't need a left 90 at the very end, because like you've already drawn the last part of the square. So there's a small little square to the right of the original square. All right, and this is how I do it. Any questions about any of those? Again, you'll be getting this updated code after class, so you can study it for sure. It's a fun one, I think. Useful. And so, yeah, eventually we're going to learn how to color in these things, have different line colors as well. Like, it'll still be pretty cool, right? Even though we're not in Scratch anymore and it's hard to make a game. But this is not too bad, all right? So that is, that's that example. Not too horrible. Let me save that. Remember to save that. And, yeah, I just want to show you a couple more things. And then release a lot of assignments. Okay, what about a triangle? Okay, I think an equilateral triangle is the easiest one, right? So maybe if the turtle starts at 0, 0, we can do the same game of drawing a triangle by drawing the bottom part. That's still flat, right? So let's say this is like 200, all right? And then like he's here. And then an equilateral triangle is 200 on each side, right? You just remember all that. But now the question is, okay, so we know that all these are 200, like 200, 200, 200. Does anybody remember what the angles are for every equilateral triangle? It's going to be the same. What's the angle in each, what is each angle in an equilateral triangle? 60, yeah, 180 over 3. So it's going to be 60 degrees. Cool, thank you. So, okay, we'll go forward by 200. Sure. We'll make a new file. Let me copy and paste most of this, actually. Not all of this, though. Let's just do the turtle shape and all that. And I'll save a new file called, like, we'll go up to shape. I'll call it triangle.py. All right, so there's that one. And so, all right, we want to go forward, Mr. Turtle, by 200. So turtle.forward by 200. And then, right, you might think that, okay, now it's going to be turned left by 60, then go forward by 200 again. There's something a little bit wrong with that. It's like the degree amount is 60, right? And then go forward by 200 again, right, because it's the same length. This is another 200. But there's going to be a bit of an issue here. See if you can try and understand it before I run it. Boop, boop. Ooh, that was not enough. You see that? That would work if you're going to draw like a pentagon, maybe. But that's off. Let's see here. What's the issue? Why didn't that go to there? Well, notice how, if the turtle went forward again, he would have gone that way, right? Really, we want to turn left not by 60, but this angle, that bigger angle. Is that, what's that called? Is it complementary or supplementary? I cannot remember between those two words. It's been too long since I've taken geometry. But it's one of those words, right? What is the... Okay, so it's a supplementary angle. Thank you very much. Yeah, I totally forgot. It's good to relearn those things. So, okay, what does that mean then? This is a supplementary angle. How do we solve for this? We can solve for it, right? If this is a straight line and this is 60 degrees, the other side is 180 minus 60 degrees. See that? That's how far we need to turn left by. So it's 120. And we could totally It's hard to read, isn't it? We could totally, how do I want to do this? Make it visible still. 180 minus 60 degrees. That's the degree amount, right? We can say, okay, yeah, we can do the math ourselves and be like, okay, that's going to be not by 60, but by 120. Or we can remember that we're in Python, and Python will do whatever we want. So, like, even if you don't want to do the math, just like, all right, I know it's 180 minus 60, just let Python figure out the rest. Just type 180 minus 60. It will compute 120. And that's going to give me the right amount. Right? And then if I do the same thing by that same logic, just like for the square, right? Turn left by that same amount again, go forward by 200, you will get where you need to go. Okay. So that's the secret. So that's perfect. I'll just separate these so that you can see the different thoughts. But it's going to be all of this all over again. That's it. And we have a beautiful triangle now, equilateral triangle. I love it. Are there any questions about that? Does that make enough sense? So how we went from this diagram to this code that drew the diagram. Beautiful. I like it. All right, that one? All right, because I got one more example. It's the hardest one, right? So I would like to draw my initials, all right? My initials are L and N. And you can imagine that you're going to draw, you can think of drawing your initials if you like, while I'm doing mine. But this is just a good example of like, okay, an L is kind of easy, right? It's just like part of a square, essentially. Maybe you can make it wider than it is long, that's fine. But the N, right, the N part of my initials is horribly difficult, right? They got the weird line there, like how do you figure out the angles involved? So let's figure this out, okay? So the first thing we should do is like plan it out. I would like to draw an L and an N, please. Let's figure out like the widths of things, like where everything is going to start. So I like to draw something like this. L and N, and I need like a blueprint, don't I? Like we're like architects. Let's say that each character is as wide as the other. So both of these will be like, I don't know, let's say this is 125 wide. This will also be 125 wide. All right? And then, like, an L is not supposed to be perfectly square. Like, it needs to be a little bit taller than it is wide. So let's say this is 200. And that means this one is also 200 tall. Okay? That's the goal. And then, now the question is, where do we want this to start, right? Like, what are the coordinates for where this should start? Because, like, if it's in the middle, you start in the middle, like, you're drawing an L and then an N here. It's kind of, like, cut off. It's not really centered. So maybe instead of starting at 0, 0, we can move over and up a little bit. And then the L would, like, be there. That would be nice. Up a little bit and then just start drawing there. All right, so like over and up, like maybe a couple hundred each, right? It's like negative in the x, positive in the line. So maybe we can move over so like this can start at like negative 200, positive 100. That would like be something like that. Seems pretty nice because then it would be centered as well, right? It's positive 100. And if this is 200, then this would make this coordinate, right? Negative 200, negative 100. And so that would be perfectly centered on the screen, if that makes sense. That would be cool too. All right, so that's a good idea, I think. And so we want to like get over to there before we do our start drawing. So that's cool. We almost have all the information. We also need to know how big this gap is, right? How wide is this gap between letters? And let's say, I don't know, probably not to scale, but let's say a good number that I chose last time was 40 units. Okay, so 40 units between characters. And so now, like this gives us all the information we need. This is the complete blueprint. If you know this starting location, the widths and heights and gaps for everything, like it is, nothing is ambiguous anymore, right? You can draw this perfectly now. So the question is, how do you do it though? Okay, so we can do the L pretty easily. Let's get over to this place and start drawing the L because we know how to do that. All right, so let's get to here. Face downwards, like go forward 200, turn left by 90. It'll all work out, just like a square. All right, let's do that one, because that's easy. But at the end, ooh, it's going to be a little difficult. So I'm going to steal a lot of the triangle code, and I'll make a new file, and I'll call it initials.py. All right, initials.py. And get rid of pretty much everything except for the shape. And so here's my goal again, right? I would like to draw that. right? So I need to get over, right? The turtle by default starts at 0, 0, facing right. So we'd like the turtle to face left, don't we? So we can like go over left 200, right? And then up positive 100. So we need to get the turtle into position. So if we say like turtle dot set heading, right? Turtle dot set heading, how do we make him face left? And that's 180, right? Turtle dot set heading 180. So now he's facing left, going that way. And if we tell him to go forward now, he'll go left. Right? And so if we told him to go forward, let me just show that to you first of all. Initials. Look at him. So he's ready to go. And so if we want him to start at negative 200, 100, just like move 200 now. Move 200, go right, and then go 100. Yeah, that'll get him into position. So if he's sitting right there, faced like that, and we want to go here, we're going to say turtle.forward by 200. That'll get him like right here-ish. Then we want to make him like he's facing this way. Turn right 90 and go up 200. Let me just show you that first of all, because it's a little bit off. So he's making lines right now. We want to turn off those lines, don't we? So we'll say turtle.up before we do any of that. So that's a little bit better. They say turtle.up. So now he's over there, and we want to make him go up a little bit more. So he's at negative 200, 0 right now. We want to make him go up to negative 200, positive 100. You see that? So he needs to turn right, and then go forward 100. Okay? And so just like there was left, there's right. So turtle.right by 90 degrees, right? And then I'll give him in the proper position. Let me just show that to you. Boop. So now he's ready to go forward again. Turtle.forward by 100. And that will finally put him in the right spot. Cool. And now he's ready. He's at the tippy top right here. That's the top of the L. Okay? Any questions about how I got him there with this code? Like, that's our starting position. Okay? And so now, now I'm ready to draw. I'll put the tail back down. So now we're ready to draw. And so it's time to draw the L part. Draw the L. Okay. So if I'm here, turtle's facing up, I need to make him face down. Right? He needs to face down now. So I can go forward by 200 with the tail down. Alright. So to face down, just immediately, like you could tell him to do a 180, that's fine. But you could also use a set heading, like set heading to 270. Yeah, that would always face him down regardless of which way he's facing currently. So I think that would work. We'll say turtle.set heading 270. And watch how this is going to put him in the right spot. Where do I want? So there he is. He's facing down now. That's what I wanted. So there he is. Okay. And so now, boop, I can go back here and tell him to go forward by that 200, right? Turtle.forward by 200. And we're pretty much done with the L at that point. There it goes, forward. And then I'm just like, okay, think about it. It needs to turn left by 90. Imagine you're the turtle. It's got to be left 90, right? And then we can go forward by 125. Okay. Left 90, and then turtle.forward by 125. And that will draw my L. Boop, boop. Beautiful. All right. So that's, it's hard to show you all the things I want to show you once, but there is the drawing. Are there any questions about how we got there? Hopefully all the steps seemed logical, even if like together it might be a lot to you right now. But that's okay. That's why I'm giving you this code to study. Any questions about what any of that's doing? Because if I'm done with the L, I need to get ready to go to and do my last name initial, right? At the end. So, okay. I need to cross this gap. Cross that gap. So I need to go forward 40, right? That's essentially just go forward 40 because you're already facing right. That's perfect. But we need it to be a gap, don't we? So instead of saying just this, turtle.forward by, what was it, 40, this is the space between the letters, isn't it? Let me move this up for y'all. Space between letters. Okay. If I just keep it like this, remember that his tail is down, so I just extended that L. I wanted to take his tail up before I went forward. So turtle that up, then go forward. Then we're good to do it again. We're good to make marks at that point. So we can do turtle dot down once more. All right, if I run that, now he's crossing the gap in style, and now we're ready to draw that in. Yeah. So we can get most of the way. We can get most of the way, or like maybe one to a third of the way of the app, and then we run into trouble. All right. So I can say turtle like turn right or turn left by 90, go forward 200. I'll get to that, right? That's not too hard. Because if he is here, we want to turn left by 90, right? Because then it'll get ready to go up. So this is draw the N, right? So turtle dot left 90. Alternatively, you could have done set heading, also 90, I guess. Left 90, and then turtle dot forward by 200. Boop, boop. There it goes. And now it gets difficult, all right? Because what in the world, all right, let me use green for the hard parts. What in the world is this angle, right? It's like if you want to go left, or sorry, we want to turn right, don't we? We want to go, like he's facing this way. So not only do we need to know this angle, we need to solve for this angle. Turn right, Mr. Turtle, by that amount. 180 minus question mark, right? So, yeah. Anybody have any ideas about how we can figure out that angle? Very good. Yeah, so this is, you thought you would never need to use geometry ever again. I'm here to tell you that you're finally having a use for it in the real world. It's to draw stuff, all right? So, yeah, we can use tangent. Perfect. So notice that we have the opposite and the adjacent, and this is totally a right triangle. Disgusting, isn't it? But it's going to work. It's perfect. It's exactly what we need here. So yeah, we have opposite over adjacent, so that that means that the tangent of this question mark angle is equal to 125 over 200. And so to solve for the question mark, I'm going to use the inverse tangent, right? Inverse tangent of 125 over 200. And that will give you question mark. And there is a function for that in the Python math library, believe it or not. So that's beautiful. We can now use the Python math library to finish this off. And there is a tangent, for sure. It's just called tan. It's normal tan. It's called tan. The inverse tangent, another name for it is arctangent. And so it's atan. We're going to say math.atan of our ratio. And it will give us the angle back, not for use in the turtle yet, though. It's going to give us the angle back in radians. All right, so we're going to get that in radians, and then I have to convert it from radians to degrees. Okay, so we're going to get that back in radians by using atan. Let's just get that right now. So we're going to solve for the angle, okay, by using math.atan. So I need to import the math library, first of all. So I already imported turtle. And now I want to solve for this tricky angle. Okay, so it's going to be math.atan, right? Inverse tangent of 125 over 200. You can just do it like that. It's happy. And then, like, we can store that in a variable, by the way. You can just be like angle, whatever it was. Call it angle. Yeah. But right now it's radians. All right. So there's a way to convert also in the math library to convert radians to degrees, because that's what the turtle library needs. It needs a degree amount. And it is very simple, the name of it. It's just you say math.degrees. So it's going to take something that was in radians and convert it into degrees. There's also the inverse for that. All right? So I'll say math.degrees. This is something that's radians. To make it degrees, I'll just wrap that around another call. Math.degrees, please. Whatever that was, convert it from radians to degrees. Store that in angle, whatever it was, something disgusting probably. We don't even need to look at it. We don't even need to know what angle that was. I just need to know, I just need to have that at my disposal so that I can turn right. Yeah, I need to turn right by 180 minus question mark, 180 minus angle. Okay, and that's going to get me in the right spot. Whatever that was, whatever angle was, I'll just use the variable. I don't even need, you can print it out if you want to really know what it was. But just like turtle.right now, right? What we need to do is turn right by that, the complement. Did I get it right? Complementary angle? Supplementary. I'm going to mix it up for the rest of my life. Supplementary angle. Thank you. All right. So it's 180 minus angle. That's the supplement, I guess you could call that. Beautiful. Thank you for correcting me. I'll get it right one day, hopefully. Look at that. That is the right angle. That's beautiful. And so now we want to make the turtle go forward. Oh, by how much though? Uh-oh. By that amount. Uh-oh. So this is some other length. Call it L. Can we solve for that too? We can. We totally can. We can use, this is a right triangle, right? We can use the Pythagorean theorem. We can be like, all right, we know that L squared is equal to 125 squared plus 200 squared. Look at all this geometry knowledge coming back to us. And so we want to solve for L. We just like take the square root, right? Take the square root of that. And it's math.sqrt for square root. So that's going to be my amount to go forward. I'll use another variable for that, right? Boop. I'll use that, okay? So L, whatever it is, it's the square root, so math.sqrt, of what? Of 125 squared plus 200 squared. So the star for the power. Okay, so there's my amount, and like I'm facing the right direction. I just need to go forward by L. Turtle.forward by L. See that? Boop, boop. Oh yeah, so nice. And then we need to turn him upwards, and if you think about it, he will, like it's going to be a very similar angle. Okay, so like we want to turn left now, just not right though, but left. By this, it's the same angle, right? You can do, there's some properties of triangles to solve, and like notice that that's the same exact angle. Nice, yeah, that kind of thing. Those kinds of rules. It's been way too long for me, but hopefully it's still fresh in your minds. All right, say a turtle left by 180 minus angle. If you try enough options, like that's the right one, and so that'll get him. You could have also just like faced straight up, like turtle that set heading to 90. But this is more fun, right? And now we're ready to go forward one last time by 200, which is the height. Whee! Gorgeous. Good job, well done. All right, so that took a lot of effort, I think, didn't it? So we made it work. We got our answer. We did it. And this was the code for it. Were there any questions about any of the pieces? You could do it for your own initials. If you have like curvy letters, you can just use boxy letters. That's fine. But like, think you could do the same thing? All right. Just like if you've taken like a calculus class, you've learned like you had to learn about derivatives the hard way before you learn the easy trick. All right. So I taught you the hard way to draw stuff. There is a trick. Okay. There's something called turtle.goto that solves all of these problems that we just had. Okay. So let me show that to you. Oh, I forgot to stop attendance. So please do attendance if you've not yet done that. I'll stop that eventually. But there's turtle.goto. Alternatively, like a lot of these functions have different names. Like they're all equivalent. Turtle.goto, turtle.setPos, turtle.setPosition. But we can give it x and y coordinates, and that will just warp the turtle to those x and y coordinates. So regardless of the orientation, like the direction of the turtle, they'll just warp him there. Make a line if the tail's down. So watch. We could have made this much easier on ourselves, but this was more fun and more helpful for you. But I could have just said like turtle.goto, like, and then figure out what direction. So like right now the turtle's facing up, If I say turtle.go to 0, 0 right after that, he's just going to warp. Regardless of his direction, he's just going to warp right to 0, 0. Whee! And then he made a mark, though, because his tail was up. So that's going to save your life, right? That's the easier way to do it. But this was such a good example because it taught us about the math library some more. I think it was useful, right? But GoTo, you could have solved a lot of these problems with GoTo and just figured out what coordinates are all these pieces. So that's my last answer. Any questions about this example? Because I think that's all the slides that I have for us for the day. So if we're happy, I'll give you all this code, remember, so you can use it as you're working. But I have several things for you now. So all right, you got an essay due, you've got a programming assignment due, you have so many things. So let's just go through them one by one. I need to give you a new essay first, all right? This will just be a short one, so I know you're probably thinking about the midterm too. So don't worry, this is due quite a ways away too. So you got 2 weeks to do it. But this will be a 500-word essay, all right? And here are your goals, your directions. I have an article for you to read this time, all right? So here's a link to it. It's an article on a machine called the F24, right? So please read it. It's a very sad story, unfortunately. So I'd like you to read about that thing using that article and write a response to what you've learned during that article, all right? So try to highlight any false assumptions that were made by the companies who made this device. It was a medical device. You can also look at the Wikipedia page. There's some more information. And just tell me what you would have done differently, because something really, really bad went wrong, and it has to do with computer science. All right, so it's a really good article for you to read and an essay to write about. But yeah, just tell me what you would have done differently and try to pick apart what they messed up on. All right, in your own words. And so yeah, just do that for 500 words. You don't have to cite anything if you don't want to, but you might feel the need to cite the article. That makes sense. Just read this article about this thing. There's a big issue with it, and just write a response. Tell me what they did wrong, what you would have done differently. Okay? Does that make sense? It's not too bad. Just 500 words. Not a horrible thing. And then yeah, that'll be due 2 weeks from now. Okay? 2 weeks in a day probably. So that's your first essay. We're good with that? Because I just have we only have one lecture this week because of the midterm on Wednesday. So it's just gonna be a lightning round, me giving you things. So that's your essay. All right. Next, I need to give you a programming assignment. So you got one of those due, don't you? So here's a programming assignment, and I'm going to force you to do your initials. In Python. I also want you to do something else. I want you to do initials and graduation year. All right. So here's your goal for your program. All right. This will also be due week 10. I'd like you to write a program that uses turtle stuff. It's a Python program. Your first Python assignment. To draw your initials, and then also, just for fun, to give you more practice, I'd like you to also draw the year, just the last 2 digits of the year that you intend to graduate, either from here or from a 4-year college after you transfer. So for me, I would have done LN20, because that's when I graduated from my last degree, okay? So, do your initials as well as your graduation year, so 20, or not 20 for you guys, 24 if you're going to graduate this year or something, I don't know. But yeah, initials plus graduation year, please. That's what I want. You don't have to use any fancy angles. You can use the .go to like I just showed you. And then if your letter has a C or a B, that's one of your initials or something, you could just use boxy letters. Just boop, boop, boop. Just use hard angles. It's that'll make it easier. Okay. So there are ways to draw curves in the turtle library. It's if you want to know. It's turtle.circle to draw parts of a circle, so that could be helpful for you. If you want to go crazy, go for it. So that's that. But yeah, and you can also just do the microwave style digits as well for the numbers. Just make it easier on yourself, unless you'd like a challenge. That is my goal for you. So remember to do your initials, and then also just the last 2 digits of the year that you want to graduate. So 4 characters total. Okay, does that make sense? So yeah, that should be fun. And this is the first assignment. For those of you who have programmed before, I want you to do the Python assignments too, please. Just make them fancy. Use the curves, right? If you've been a programmer already, make it as difficult. Make it at the level that you're at right now. So yeah, everybody is going to do the Python assignments from now Okay, so there's that, and yeah, just to submit it once you got it working, please just like do as you've been doing. Give me a video, explain your code to me. Doesn't have to be long. Let me watch it work. And then remember that when you're writing Python programs, you want to make a brand new file, new file, right? And have a whole file to then go and run with the run command there. Don't just type out your code in the REPL, right? Because then you can't change it, and that doesn't work. This is not where you write code. You write it in a brand new file. Okay, just remember that. All right. So yeah, that's your programming assignment. Also due in 2 weeks. We good with that one? Everybody's doing their initials and their graduation year. All right. So that's that one. Got a couple more things, and these ones are not like things that are going to ruin your life or anything. Got an extra credit assignment and also like a mid-semester thing. So we're in week 8. There are, 16 weeks of classes plus an extra week for finals week? Or did I get that wrong? No, there's 18 weeks. So there's 17 weeks of classes and an extra week for finals week. So almost got it right. We are about in the middle, okay? About in the middle of classes at least. Could have been either this week or next week, kind of. What I like to do for all my classes is give out a little feedback survey. It's completely anonymous. You click this link. It'll take you to a Google form. Like, I don't know what you wrote here. I can't link it back to your name or anything. So go crazy if you'd like. But I just like you to tell me how the class is going for you, so I can get your feedback, and if something's going horribly wrong, I can fix it by the end of the semester, and it will also help me for all my future CSCI classes that I teach after you guys. So yeah, just fill this out in as much or as little detail as you would like. You can just skip questions if you don't have answers, but here's kind of what I'm asking, and it would be helpful for me if you filled it out. It's give me 3 things I should keep doing, stop doing, start doing, just to help you and make the class better. Okay, so yeah. I would appreciate your feedback if you're interested. So, yeah, completely anonymous, not for a grade, obviously, but it's something I like to do. All right, so consider filling that out if you would like. That's available for you now. And then the final thing that I want to say today is to give you an extra credit assignment. All right, so this one will be up to 5% extra credit on top of your final grade. So use it if you need it. Or just for fun. I'd like you to learn a new language, okay? So I'd like you to learn JavaScript. If you've never learned it before, it's very, very similar to Python. If you already know JavaScript, you have to talk to me because I need to give you a different language to learn, right? But a lot of us probably have never used JavaScript before, and so I would like you to try to learn it alongside Python so you can see the similarities, right? This will be an extra credit assignment for you. So Khan Academy is a website that lets you learn cool stuff, and it has a JavaScript, a bunch of JavaScript lessons, right? And so just go here, boop, and do a few of them. Right? So there's a few little units, so you have to make an account, sadly. You got to make an account, and then you'll go to these things, this is the first part, intro to programming, or what is programming? You'll watch the video or whatever. And once you have an account, every time you complete one of these things, one of these lessons or whatever, you watch the video, you do the little assignment next to it, it will put little markers on all these. That's how I'll know, that's how you're going to turn in, I did these things, okay? It'll put a little star here or something just to indicate that you've completed it, okay? So that's what I'll be looking for when you turn it in. But you'll go to all these, and there's some drawing in JavaScript. It's just a different language, okay? So if you would like to do the extra credit, so I got a bunch of cool stuff, just some instructional videos, and then it'll give you some little mini assignments for each of those. If you would like just half of the extra credit, just 2.5%, please go through and complete, get a little star next to every lesson, project, challenge thing, up to and including variables, right? So all the way down, intro to programming, drawing basics, coloring, variables. So complete this one, right? Get all the stars next to all those things. And then you'll turn in a screenshot or maybe even a video, doesn't matter, just showing me that you've completed all the pieces. I got checks next to all of them. Does that make sense? So yeah, that's for half the extra credit. If you want the full 5%, then I want you to go all the way up to and including the interactive programs section. Right? All the way down here, past variables, animation, all the way up to and including interactive programs. All right? So this one tracks the mouse movements, and it's drawing cool pictures. It's fun, honestly. So you'll learn cool stuff like that. Okay, so yeah, all the way down to here. See how it's like there it goes. It'll do something like that. You want to get it all the way to the right. Yeah, that tells me that you did it all. Okay, so yeah, I guess, yeah, I think it's hard to do a screenshot of all of this at once. It would just be multiple things because you have to scroll. So just like give me a quick video scrolling through and showing me that you completed all the sections, right? So that's for 5% all the way through that one. Does that make sense? So yeah, I'll give you a few weeks to do it. There will be a due date. It's like it'll just be like midnight. It's not a big deal. 10, 10, 10, and I think where are the days off? 18th versus 19th. Which day is which? I don't know. We can. I don't really care. Like it's gonna be here. I'll give you until the 20th. Why not? Here. October 20th. But that is it. Okay. So if I've given you an extension in class for certain assignments because you work or something, that only applies to normal assignments. It doesn't apply to exams either. But this is an extra credit assignment, so it'll be due for everybody at midnight, 11:59 p.m. on the 20th of October. Okay. So that is that. So if you already know JavaScript, we will find something else out of a similar difficulty to get you extra credit. All right, this would be too easy for you otherwise. All right, I think that's all I want to say about that. Does the extra credit assignment make sense? All right, so sorry to bombard you with all these things. It's because of the midterm. I don't have 2 days to do it. I just got to get it all out in one day. But I think that is finally everything. That's everything that I wanted to say and give out. Do we have any last questions about anything we talked about today? All right, well, that's all I've got for us then.